There will be less fancy slides today and a lot of hands-on demonstrations. Hopefully they will all work smoothly. So I represent AG Projects. If you can subscribe to our Twitter feed or you are already there, I'll post a link there later. Maybe somebody wants to actually participate in this live demonstration. So what is AG Projects? We're a software development company based in the Netherlands. I'm the AG from AG Projects, as you can imagine. We are traditionally a server-based company involved from the start of the SIP Express router project in that ecosystem, which split it in several projects afterwards. We are an OpenSIPs contributor today, so that's our affiliation today with regards to the former ACR ecosystem. Some of you may have heard or not, you have the PBX crowd, Asterisk, FreeSwitch, and you have the SIP proxy crowd. So I'm with the SIP proxy crowd. We made software like Media Proxy, which is the first distributed RTP relay for the SIP proxy. And we have contributed other components, all of them in the public domain, related to features or functions that are required when you want to run a SIP infrastructure. The SIP server alone is not enough. So we spent time building some elements which are critical for such infrastructure, like rating. CDR tool application has been used for rating for many years in that context. Call control allows prepaid calls, and they're all integrated, meaning OpenSIPs can talk nicely to Media Proxy and call control, and the rating works nicely with all these elements together. Also, we focused on building elements, which seems that nobody have really spent time on. We loved SIP from day one for what it promised, in the sense that it's session agnostic. And we always, I dreamt about having a complete SIP client and server solution, not just for voice, but for any type of media that people would use, like chat, file transfer, video, screen sharing. That was the promise of SIP. Unfortunately, that didn't happen, didn't materialize for many reasons. So still today, SIP is used for voice over IP only most of the time. Nevertheless, our company spent a lot of time probably the most time in going beyond VoIP with SIP. So we built, in the end, after many years of experience with the server side, we started a project where we wanted to make the SIP client, which was supposed to deliver, and in the end it delivered, the original promise of SIP, that is basically multiple types of media in the same session. And we built an SDK which allows anyone to build a fully fledged client based on such features. So this is what they call SIP-Simple Client SDK. Is a development kit. It's written in Python. And of course, when I say this, some will run, some will love it. But it was a decision we made. We're a Python-based company. Most of the software we develop, if not all of it, 90-something% is in Python. So that was a choice, of course, that limited the adoption. But then again, I believe there should be an implementation in any language that we focus on Python. So the target platforms at the time when we started were the desktop. We wanted to go mobile, but that was way too early. I'm talking here about 2006-07 when we started thinking about this. And when we had the first implementation of SIP-Simple Client SDK, it was, I think, 2008 or 9. So mobile was starting to come, to replace a lot of desktop applications. But this toolkit was built or developed ahead of this. Anyway, the library works on any system that runs Python. So that should include a lot of platforms, not those where originally developed and tested the software. So this SDK is very powerful, really. It has all the blocks that you might need, and you need in order to build a client. Everything is there for you. You can have account management. Everything is asynchronous, non-blocking. All the parts, basically, that you need for storage, for configuration, there's a framework and an API for all these very complicated things, if you think about it, in terms of a multi-account SIP client, which supports multiple sessions and all these things. Of course, it's a SIP client, so it supports SIP and beyond the basic protocol, things around the SIP protocol. Location discovery, as far as I remember, even today, it's a struggle to get a proper DNS lookup to find the next hop. We did it properly from day one, so you could actually use TLS because you could locate, the port where the SIP server is running by just doing the proper DNS lookups. So it works very nice. It works for a long time. Probably was the first client that properly did all this NAPTER, SRV, a record lookup. NAT traversal was built in properly and for all media types. Again, this is not just for VoIP, so we adopted MSRP as the protocol for non-VoIP apps specified by the SIP-Simple working group. This is a media plane which didn't really get adopted much, but is part of the SIP specifications, and we're proud to have implemented all of them and also be part of that standardization. So RTP provides the media plane for audio and video, and MSRP provides the equivalent for non-real-time audio video, and that is typically chat or file transfer. But basically it's a TCP pipe that two SIP clients negotiate, and over that pipe you can basically exchange any type of data. It's up to your imagination what you can do. MSRP is like an email carrier. You can put any type of data and express what type of data is by using like MIME envelopes. So of course we supported voice and video over IP. People call very often a SIP client a VoIP phone, and we have to comply with that. We don't like to call this a VoIP phone because it goes beyond VoIP. So we call it a SIP client. Of course, voice and video over IP is part of it, but it goes beyond basic calling. So we have multi-party conferencing, again following the IETF standards, which were also developed at the same time and finalized at the same time as our toolkit was being developed. So it was a nice synchronization in time with the standardization efforts. We support instant messaging, and probably we're the only client that properly supports all instant messaging protocols standardized for SIP, namely MSRP protocol with its chat facility and the things that go around that, and also multi-party instant messaging using MSRP protocol. We implemented desktop sharing based on a private, not private, but it's not the standard, it was a proposal. Nevertheless, it works very nice. That's VNC over MSRP. So VNC is the standard client you have on a desktop to see the desktop of another computer, and with this toolkit, basically you can pipe a VNC session. We implemented all presence-related stuff. It was a lot of work. Unfortunately, people didn't adopt SIP presence because of its complexity. Nevertheless, everything that you dreamt about presence, if you really have presence implementation in your server side, for instance, you can use this to troubleshoot, to test, to actually check all the call flows. So basically, we support subscribe, notify, and publish mechanisms in the toolkit. We have brilliant encryption, not just hop by hop and the classic TLS and SDS, but we have end-to-end encryption for all media types in the toolkit. So you can have audio and video end-to-end encryption using ZRTP key exchange. And for chat and file transfer, we support OTR, which is not an IETF standard, but is highly adopted in many clients. And not only this, but they're all integrated together. So you can create a session with multiple different media types, and all of them are encrypted at the same time using the same key exchange. So it's very easy to create, by default, encrypted sessions for all media types. And this is how the SDK looks. We started building on top of PGSIP, which is the part below here, which gives us basically the SIP signaling, the parser, the RTP engine. And we started building a lot of blocks on top to create some abstractions that make it, in the end, for the developer of such endpoints, make it an easy task to build and hide all the complexity of all those tons of protocols in those lower layers. So end up with some elegant API Python style to manage accounts, manage sessions, deal with presence, deal with the configuration of the client. And basically, this is an API which is written in Python style, easy to use actually. It's self-explanatory if you go through the code. So the original targets were the desktop operating systems, which is Mac, Linux, and Windows. So the SDK was designed for this desktop world, let's call it, not for the mobile originally. So once the SDK was there, well, it's all nice, but if there is no client out there, it's not pretty good and there is nothing to show about. So I'm sure you want to see who is actually using this SDK in the end and how it was used. So we had some interesting presentations a long time ago. Some people really built the first hardware. Let's call it, well, they call it Projecta OP2. Basically, this is the first hard phone using the SIP-Simple Client SDK. It was very fun when it was demonstrated. Basically, they built on a Raspberry Pi, they run our software there, and they made a nice, how do you say, gadget. It made up for a good presentation at the time. But this is not just a toy. So we thought about this toolkit should have multiple facets, and we also needed test tools for our SIP infrastructure. So with this toolkit, you find some gems that probably you have never heard about, but after you see them demoed today, maybe you will go and check them out. Basically, you have command line tools for all SIP call flows you may imagine. And they are nicely written, very elegant, they work, they are tested, and they can be used for a variety of purposes. So these scripts which come with they are basically command line, like in the bash shell, you can start them. And you can make voice calls, you can make chat sessions, you can do file transfers, you can subscribe to presence. And I will show this actually, I will demo it shortly. Then we built Blink, which is basically what was the original intention, is to build a client, but we started doing it properly using an SDK with APIs exposed so that you can build a GUI on top, which is decoupled from the underlying mechanics of all the protocols involved. So anyone heard about Blink here? So the client is free for Linux, Windows. On Mac, it's in the app in the Mac App Store. However, there is a free version that runs integrated with sip2sip.info. So I know you want to see the demo, and I will go directly into it. Right, so we're in a terminal, and haven't you always wanted to have a tool, to check if your SIP server is alive, and if it responds to one call, does it work? Is it there? Can I test it quickly without spending half an hour trying to make some synthetic test with a lot of software out there, which is very hard to use. So for this purpose, you can use this tool called SIP Audio Session. So with this tool, you can make a call to SIP URI. Right, so this is an echo test, and I made a call. You can nicely change the output and input and alert devices for this. Using just with one key only. So you can toggle a lot of stuff, like even the SIP trace. So you can make a quick phone call, and you can see if your server is working. And the nice part is that you can put this actually in a cron job, and it returns the proper code that you may use in a tool like Nagios or other things. You know if the session worked, and what by this means if SIP signaling worked and the media worked. So you know for sure your server answered, the call was answered, media was exchanged. So you can put this you can use this in other software that requires such capability. You can also use it in the background waiting for an incoming SIP call. So let's try to make one. So I will call myself from Blink, ag@sip2sip.info. So there is an incoming audio session. I'll say, hey, answer. Where is the answer? Yes. Hello. So we have an audio session end-to-end between two clients. You can see the remote agent. can put it on hold. I can hang up. So it's a very easy to use tool for one single audio call. Whether it's incoming or outgoing, you can basically use it interactive or in a batch. And it works properly detaching from the terminal, and you can put it in the background basically. Another tool is SIP register. It's a very simple question. Is my server, working? Can I register? Well, with this tool, you just send a register, see if it works, and if it does, just quit. Again, you can put it in other scripts that may use the output of this to check if a SIP registration works or not. You can know for sure it works. You have various parameters you can give. You can say register 10 times and then quit. You can basically set those parameters that are very helpful to automate testing for your SIP infrastructure. Then the most complex of it and the most useful in the end, because it has all built in an interactive client, is called SIP session. And this is basically a client that gives everything that SIP promised to you in a console. So I will type help. You can start, as you see in the help output, various commands we can give. So we can start making an outgoing call. Of course, if I call in, I'll be able to receive incoming calls. And the nice thing is that I can toggle the trace for every protocol involved on the console in real time so I can see the packets. So let's make a test. We make a call to this room we prepared. Basically, we'll make a multi-party conference call. Right, I'm alone there. So I'm connected to a SIP user agent. Let me lower the volume. So I'm connected to a SIP user agent called Silk Server, which we're going to see later in another demonstration. You can see the RTP endpoints. And you can see actually in this single call the capability of the toolkit. Basically, you are able to join a conference by using a landline, using a phone number. You can enter the conference using an XMPP client. If it supports audio through the Jingle extension, basically you can have a call on the other side with an XMPP client, with a SIP client, or a WebRTC interface. And we're using end-to-end encryption with ZRTP. And it's also a chat client. So basically you're in a chat room here using MSRP protocol. If you have ever, oh, there is somebody there. If you have ever been curious how MSRP looks like, you can do trace MSRP. And now it will display what's going on under the hood. So you can see all the packets, part of the protocol, which is a media protocol. So you can troubleshoot your server if you have an MSRP implementation. You can see all the packets flowing back and forth between your client and the server. And all this trace is saved in a file, so later you can use it to check whatever happened. Same is valid for SIP. So you can enable SIP trace with this. Now all SIP packets exchanged with the server are logged and also displayed on the console. So let's say I'll put the call on hold, and you nicely see actually the re-invite going out, and you can see the SDP, which in case you want to troubleshoot something comes very handy to see what's working or what's not working. So I will toggle back the trace. So these command lines, you can use them for real, like having a desk phone in your command line, and you can use them for troubleshooting whenever you need to check if your server is working. So you can use them interactively or in a batch, or in another script, embed them into something else. And I will show you something that very few have seen. How do you do file transfer with SIP? Basically do send. I prepared a file here, and I'll send it to my SIP URI. Oops, I think I missed the the parameters are different. Astricon txt. Okay, I go to my SIP client. It's also ringing. Accept. So you've seen actually the MSRP file transfer capability of the toolkit being used end-to-end between a GUI client and the command line client. And this is a great tool to actually send even, if you're in a data center doing some work, you can use it quickly to get some files over the net without much fuss. If you have another SIP client like this on the other side, or your coworkers are using something like Blink, you can immediately get the file in your console to do some works. It's a very useful feature. I use it several times. Sometimes I need the file. How can I get it when you're repairing a server in a noisy environment and you have no time, you want to focus on the task. I just need this file. And this tool came very handy to actually move the file around. You can record the calls. So the audio can be saved for later in a WAV file. So all the session can be recorded. Again, this tool, once you look at the code, it's very easy to enhance. It's very easy to actually change. You can embed it into other tools. The code is very easy to follow, actually. It's Python code. For those who like Python, you'll really love it. You can do call transfer. You can create conferences, add, remove participants, and you can have even multiple calls in parallel. Like I start another call now. So I can see now I have 2 sessions ongoing. Let's turn off the MSRP trace. You can see the statistics for RTP. I can check the packet loss. I can check the jitter. Going to the other call, so I switched calls. So it's basically a multi-session SIP client in the command line. Now I hang up, I bail out. Nice, elegant, easy to use. Tons of features, and everything is reachable with one key press or a very simple to use command. Troubleshooting probably is the first use for this, because of course on a desktop you'll always like to use something fancier. However, if you need or ever needed a command line SIP client, this is it. It's part of the SDK, it comes with it, so you just do basically the installation, you follow the instructions, and you end up with these tools ready to run on your platform, which is a great thing, I think. So, continuing with the presentation, how many minutes do I have?
4 more. Well, you have 19.
Right, so this was the demo. So where's the WebRTC part? Here is where it gets very interesting. So you saw that this is a SIP client, a SIP SDK. So we wanted to go mobile, but we couldn't because it's tragic to run Python on a mobile. So we ended up with a hybrid. Basically, we built an application server called Silk Server, which actually uses the whole SDK as the server side of SIP, let's say. And that allows us to go into other places. So actually, we ended up supporting the same SDK through a server component by implementing WebRTC in the server side. So we ended up with this, this hybrid SIP server with WebRTC interface by which you're able to actually tunnel into the SIP world and all the power of the SDK from the web. So what is Silk Server? Basically, it's a server implementation of several protocols starting with SIP, and is built on top of the same SIP Simple Client SDK, but this is a server. It's an application server. It has a lot of powerful features, and you can use it without spending time to understand those things necessarily. So if you wanted any of these features, you don't have to program anything. The whole thing you have to do is apt-get install. Everything works the moment you install it. There is nothing to set unless you want to. So let's say you wanted XMPP interoperability. You have a SIP domain with your user base and you want to make it reachable for XMPP, for all media. How do you do that? Well, there are tons of solutions out there, but nothing as simple as Silk Server. You just do apt-get install. Of course, you want to know at least the domain name is responsible for. You'll put that, and that's it. All traffic for your SIP user can be bridged out and can receive calls for the XMPP. So the XMPP gateway was the first useful application. It's transparent end-to-end. So if you have a SIP domain with SIP users, user@domain.com, all basically the same users are reachable from XMPP on the same URI without any complex mappings, any translation tables or anything. So your SIP domain can become XMPP ready by just installing Silk Server as a border element. Then we build a WebRTC gateway, which acts like a web server. And the web server hosts a page, and the page basically gives you a JavaScript entry point into the powerful SDK features. And then we started building applications standalone like WebRTC Video Conference, which gives you a fully fledged multi-party video conference using WebRTC client. And also, we tried to make it SIP compatible, but then again to the point of audio only, I guess, because the video part is very hairy. So Silk Server gives you these powerful building blocks with just apt-get install. You have all these primitives ready, and they're all open source, API-based driven, so you can talk to these components from external entities. So we were able to actually create the first mobile incarnation of our dream by using WebRTC, because with the classic a vertical stack on the desktop was not possible to port on the mobile. But with this WebRTC capabilities, we were able to actually to do that. So let me show you how we can do this. So if you go to sip2sip.info, you don't have to, but you can participate to this in real time. There is the homepage where actually you can introduce the conference room, which is Astricon. And that will allow you with just one click to enter this multi-party conferencing capability of Silk Server. I'll do it with my own client. Right, there are several people there already. Let's try to eliminate the microphone. Turn off my mic. Okay, so we have 5 participants. I think on the left, it's a mobile there. I think it should be tilted, but we are 5 people in a conference. All this facility is basically available by just doing apt-get install and pointing your browser or the pre-made clients we made for this to a URL. So we can share this. It's all open source. All open source. You do plus, you can copy the URL.
Have you made any type of software on that? It'll be quite. Oh, they will.
Let me check. Go on Twitter. So if we just tweet this, I hope it will crash. I wish to see it crash. I don't know. 1, 2, 3, 4, 5. It's designed for, the rooms are designed for 9 participants. And the beauty of it is using the bandwidth of only one single call, the whole conference. So it doesn't matter how many participants there are. The bandwidth used by each participant is just equivalent to one end-to-end peer-to-peer call. So we have 1, 2, 3, 4, 5, 6 clients now. Let's put Gaston on speaker because we like his haircut. All right, we can choose 2 speakers. So now we can focus on these 2 very important persons, Timon and Gaston. It's an ad hoc conference, very easy to use. And again, it's available on all the platforms, including mobile. We could not do this without WebRTC because a lot of complexity has been, dealt with by WebRTC engine that works on the mobile with no problems. Somebody turn off the microphone. Okay. So this SDK allows you to bridge multiple words together, and that is XMPP, WebRTC, and SIP. And you have the client side, the server side, and it's not meant to replace your existing infrastructure, Asterisk, or OpenSIPs, but it's a very nice addition to all these things, especially if you want to develop something yourself and you need an equivalent, well-done implementation. So we're proud to say in AG Projects that we have a lot of tools that are working properly and proper to the standards and properly implemented. So you can use it as a reference. If you build something else, you can check, hey, this is a working example end-to-end. You can actually use it for testing and prototyping your own tools. All right. So again, this software is available in our repositories. It's packaged for Debian and Ubuntu. It's installable on any platform that runs Python. But then, of course, you'll have to do the heavy lifting of building it and installing it, depending on the platform. We packaged it in Debian format for these two platforms. The software is available. We have our own repositories we maintain with a tool called Darks, but they are mirrored on GitHub. If you go to github.com/agprojects, all this software is available for download there. And this concludes my presentation.
How about